I'm really honored to be invited for this March conference, and I was looking at what it reads. It reads, Making Science Real. So what I'm talking about will be, in a way, about making real science, which is somehow close. Well, what I'm going to do is first to talk about some general principles, being somehow provocative about what learning means, about what learning science means, and then show you a research study which I've carried out myself for several years about a program that is running, like was said, for 18 years. So what I'm going to talk to you about is something that is theory, something that in a way is different from what has been spoken so far at this conference, but also something that has been running for this many years and has somehow contributed to the new generation of scientists in Portugal. So what we have here is this expression, apprenticeship. I think that we should really concentrate on this word. Apprenticeship is a way of learning that is completely different from what happens in school. All right? In English, we have these different words, learning and apprenticeship. We don't have this difference in Portuguese. We don't have this difference in French. We say aprendizagem, we say apprentissage, as meaning the same thing, but actually they are completely different. And if you follow me, I will try to explain why. First of all, learning, as we have been talking here, is something that is mediated by a professional, who is a teacher, who is an expert in mediating knowledge. Apprenticeship is learning with the practitioner, is learning with someone who is a professional, who is an expert in the profession, and it is completely different from school. So, in school you might learn physics, but you learn with a teacher that is teaching physics. But the teacher is not a physicist, is not a practitioner of physics, it's not even an expert in physics. He's an expert in mediating knowledge. So apprenticeship is learning science by doing science alongside a practitioner. And we say, how innovative is this? This is actually not innovative. This is as old as mankind. What is really innovative is school. Because apprenticeship, that is how we have been learning during the history of mankind, up until the coming of school as a massive access to learning. So that's how they learned in ancient Greece. That's how they learned in the Renaissance. That's how a painter becomes a painter. It's by learning how to paint in and with painters, okay? So how can we apply this to students and nowadays? So that's what I will try to show you. So, for that, we have designed in Ciência Viva a program that is unique in Europe. Not totally unique. I would say there's another program, very much like this one. It's called the Nuffield Scheme in the UK. In the United States, there are plenty of programs like this. Maybe it's not by chance that the culture in the United States is much more turned into practical terms and into practical learning than in Europe. So what we have designed was based in this principle of, like Derek Hodgson used to write, that the best way of learning science is learning science by doing it and alongside a practitioner. So we designed a program by which students, before coming to the university, they will go and work with actual researchers, doing actual science, doing real science. And this is the difference between school and apprenticeship. Because in school, the issue of authenticity does not play a role. We all know that in school, we learn by exercises. We learn by drill. We learn by simulating reality, by doing what would be if it would be real. So what we learn in school is not to address real-world problems. It's not to solve real-world problems. It's to learn how we will do that once we get out of school. And so that's why there is this tension between what is situated learning, on the one hand, contextualized learning, learning to do maths by counting apples or oranges, or learning maths by abstraction. So these two ways of looking at education are at the heart of the dilemmas that each teacher has in school every day. So what happens here is not in school. It's actually in a research lab, and we are talking about students of an average of 16 years old. So the purpose of the research was to look at the students' discourses while they were doing science alongside a scientist. Just to go very quickly, so the research went with 8,000, almost 9,000 students. There was an ethnographic approach, so I stayed for 2 consecutive years, summers, in a research institution looking at pairs of students, how they interact actually with scientists. And of course, we also did a qualitative analysis of what were the features they enjoyed more. And to understand the results of it, we have to go back to this idea of the difference between school and apprenticeship, and to try to see what is missing in school and how the students, what did they value particularly in this experience, this out-of-school experience, this way of learning like Leonardo da Vinci learned. So we are talking about 127 research institutions, just to give you an idea of the scale of the project. We are talking about 320 scientists. Very interesting first date. 61% of the students are girls. And we say that girls are not into science, so it contradicts totally. Maybe the question is, all this happens in the summer, all right? So maybe girls prefer to go into a lab than going to the beach. Is that it? I don't know. Maybe they have a feeling of their own future which is different from the males. But this is a reality. So this means that this kind of learning may be very appealing to the issue of gender in education. So something to look at. And of course, if we look at the different fields in which this difference applies, so as you see, the red are the boys, and the blue are the girls. And you can see very clearly that girls outnumber boys in almost all areas, all domains, all different research apprenticeships that we are talking about in all these scientific institutions. Of course, health sciences, we know. Girls are outnumber boys by a large number. It happens in many other, but still, we still have the same problem. And if you look at it, the only ones in which the red outnumbers the blue is, of course, electrical and computer engineering. and we don't move out of this. Physics, the same. So this is an evidence that the problem is still there, even when we look at the big picture and we say, okay, 2/3 of them are girls, but the gender problem persists. And we have to do something about it. So, how do the students perceive these internships based on this research that I carried out all these years? By a qualitative analysis of the answers, we see that the most important positive, when you ask them, what did you enjoy most? It is about practical work. We will see a little bit later, in 1 minute or two, what does this mean. And of course, this relation, this interaction between the student and the scientist. It's very interesting to look at this interaction because after all, scientists are not teachers, but they are interacting with students. So in a way, they are applying some pedagogy. Maybe what they have learned when they were students, maybe what they think a teacher should do. Of course, after that is the relationship with their colleagues. The idea that they are not nerds, that they have a peer support, that they have somebody that enjoys as much physics as they do, and they don't have to feel ashamed like normally it happens in school. So in this quantitative analysis, I'm sorry, if we look at what did they strongly agree more, of course, the idea that the researchers were always available. But it is the practical part of the internship that was important. We learned the theory and how to apply it in practice. So, from this analysis, I would just show you what were the dimensions that were most valued by the students. This idea that we learn the theory and how to apply it, which gives us this dimension of authenticity, of connection to real world and addressing real world problems. We knew why we were learning. The sense of purpose is of utmost importance. And unfortunately, we know that in school, it is an issue that has to be addressed. Because most of the time, exactly because they are learning from abstraction and not in connection to a real context, it's very difficult to understand why we are learning something. Of course, this idea of critical thinking and reflexive attitude was also very much appreciated. The contact of and with a professional team. This is very important also in terms of theory, of what learning means. If you are acquainted with the idea of education as a social process, so education is not just about being attracted by a subject. It's not just about knowing the facts and the theories about that subject. Learning is actually working with the tools of a community, working with those tools and talking and have a discourse that is shared within that community. That's how that young boy that in the Renaissance learned how to be a painter, he had to know how to use the tools of a painter. He had to know how to talk like a painter. And then he had to see himself as a painter. So acquire a self-identity. So these different levels have to be addressed. It's not just about the explanations, it's not just about the body of knowledge, it's not just about the techniques and the inquiry. It's also about being accepted in a community, which brings us very much to theories, social cultural theories about learning. And the data that I'm showing here is an evidence of how important it is for the students. So I met people with the same interests. Again, this feeling of sharing within a community. and the equipment. That's something that they valued really a lot, which has to do with this dimension of handling tools, tools that are handled by this community of scientists. And finally, they work with equipment that doesn't exist in my school. Finally, they felt like they were scientists, this feeling of identity. And that is it. Now we will see a practical example in one institution with Luis Cirne.
According to your expertise, do you think that these two types of learning could coexist, or each one is unique of them? I mean, learning by teachers and learning by practitioners. Could they coexist, these two types of learning?
Thank you. It is really a very pertinent question. I would like to have another presentation only about that. Okay? So, but I will take 2 minutes of your time to understand it. Of course, when one looks at what I have presented, one would just say, well, that's not for me, because I'm a teacher, I teach in a school, he's talking about research labs, so why should I listen? Well, it is possible. It is possible to do in school like in a professional research. It's possible to do in school authentic research, real science, not only school science. And how is it possible? Of course, you cannot do it without the scientists. It is impossible to make the two systems coexist if you only do it with the teachers. Because then it would be, let us pretend that we are the practitioners, let us pretend that this is a real-world problem, and that is exactly what school does all the time. It's about simulating situations, which is a very positive thing. I'm not addressing a criticism. It is how it works. But so how can we do it? Actually, we do it in Ciência Viva all the time. We started by doing that. When we started Ciência Viva, the challenge we did to schools, and many teachers are here, they know, was do science teaching in your schools. We will support you, you will do projects, but you have to have scientists there. You have to have science and technology practitioners there. So this means that you have to have a link with a research institution, you have to have a link with an university, and so that you can do this kind of authentic things. And I could give you an example of what Rosario has done, which for me is one of the perfect examples of how to connect these two things. Rosario coordinated a project that went on for quite a long time in schools, in several schools in the country, by which the students would have to map the biodiversity, the botanics of the forests around the schools. And they had to do it with scientists and with teachers. And they were not pretending that they were mapping the biodiversity. They were actually mapping that biodiversity, and they were then publishing those results, and those results are published in a book. So it is possible to do authentic science while learning science, as long as you do it with authentic practitioners too. So that the teachers learned, and the scientists learned, and the students learned. So it is possible to have these two kinds. I would go for hours to give you examples of that.
How do you motivate scientists? What is the motivation from scientists? Is it institutional motivation or just personal motivation?
Luis will give an answer to that, because
Yeah.
he'll give an answer to that.
Come back from lunch.
But I'll give you 30 seconds, if you allow me. One thing, political will. You have to have political will on your side. In the case of Ciência Viva, we had the political will of José Maria Gago, of our Minister of Science. And so what? So that's how we managed to engage the scientific community, because each time he would go and visit a science research institution, he would take Ciência Viva with him. And then he would tell the scientists, well, you have to work with Ciência Viva, you have to work with schools, you have to fulfill your social responsibility. And when a minister says this to the scientific community, he means business. And the scientific community understands it.